Hey guys, welcome back. Sunday night, January 9th. We got, I'm actually right now, I'm cutting together another video for you guys as we speak. We got the hot water burner stuff, cleaning, tuning, cleaning up, getting the burners running good. Putting that footage together right now, but I'm noticing that we had the shop heater on and fans and all kinds of stuff, and footage is not that good. It's, yeah, of course, it's pretty obvious all my videos are pretty bad, but this one's particularly bad because the sound is horrendous. So I'm gonna do what I can with it, and just in the interest of getting this up, what we'll do is later on we're obviously this video thing is it's gonna grow and expand, and we'll get better at doing it. But for now, we'll put up these crappy videos and this bad footage with terrible sound, and as we go along we'll get some better equipment and try to make these a little better. I do got something cool here. Jenny got me this cool little smooth camera holder thingy. This thing's pretty cool. It's like this gyroscopic gimbal. It helps motion stabilization, and it's crazy. You turn this thing on and it you can move this thing all around and the camera stays like perfectly flat. So we're going to be getting some better quality imagery, but then also we need to do something with the sound, because the sound is not very good. We're just shooting these on our phones. So anyways, I would say enjoy the video, but you probably won't. We'll try to do a better job with these. What we'll do is we'll go back through and do better versions of these videos in the future when we have better recording and editing and all that stuff. But for now, in the interest of getting this information up quickly, we'll put these videos up and just redo them later. All right, guys, thanks. Enjoy what there is to enjoy. What's up, peeps? Welcome back to the channel. I'm Ben with Mechanized Cleaning Solutions. You know what time it is. It's actually Saturday. Saturday at 6:19 p.m. I just got done doing a bunch of prerequisite maintenance for tonight's video, which is going to be how to clean up and tune up a Beckett oil burner. These are the 120 volt versions. These are not the kind of burners you find in most pressure washers. For some reason, they're making most of them with the 12 volt system, where the burner's electrical system is powered by the charging system of the engine. However, these systems are better. These systems are powered by a 120 volt sort of auxiliary built-in generator that's just sort of powered by the engine. Not sort of, it is powered by the engine. There's a 3-belt pulley back here on the engine, and you got 2 belts going to the pressure pump right there, and then you got one auxiliary 3rd belt turning this little 3,000 watt generator. This is 3,000 watts at, let's have a look here, I think it's 20 amps. Let's see here, it'll run 120 or 240. Yeah, 24 amps is what you got to work with at 120 volts. At 240 volts, you got 12.1 amps. So it's about 3,000 watts. Now, wattage is similar to cleaning units. If you know what cleaning units are, the way that I don't know, people really talk about this shit anymore, but like when you're talking about pressure washers and you say, how powerful is your pressure washer? People will say, I got 3,000 PSI, 4,000 PSI, and they just talk about PSI. But really it's PSI and gallons per minute. It's really important that you include that gallons per minute. And so that the way you talk about how powerful a pressure washer is, you could say, well, it's 8 gallons per minute at 3,000 PSI. So you would take those two numbers, 8 and 3,000, and multiply them. That would give you 24,000. So an 8 GPM skid that runs at 3,000 PSI, that machine has 24,000 cleaning units. That's what you got to work with. So in electricity, you got the same thing going on. You got volts and amps, and that gives you the wattage. So you would take the voltage, which would be 120 volts, and you would take the amps, 24, multiply those together and you get about 3,000 watts. So that's when they talk about a generator, 3,000 watt generator. It's, you know, it's 3,000 watts. That's what you got to work with. If you're running that generator, if you have it wired up to run at 120 volts, then you've only got X amount of amps to work with. If you bump it up to a higher voltage, say 240 volts, then you'll have half the amps to work with, because that maximum power is 3,000 watts. So if we run this thing at 240 volts, we've only got 12 amps to work with, because that's all the energy we got to work with. So the wattage is like cleaning units. It is a description of the total amount of energy you got to work with. Okay, so before you go and you service a burner, you got to make sure that the incoming power is correct. Because if it's not, then what'll happen is the little squirrel cage fan. The way these things work is you have basically an electric motor right here. This electric motor is turning two things on one shaft. It's got a big squirrel cage fan right here in this big housing. And then also, as the shaft goes right through, it also turns a fuel pump on the engine. So, similar to your pressure washer, is when you arm this thing with power, the fan starts turning. You have an arc coming across the electrodes, which is ready to ignite diesel, which is not being spit out of the nozzle yet. What's happening is the fuel pump is still turning, but you'll notice that on a hot water burner, you got two fuel lines. You got two lines, you got a supply line and a return line. So like your pressure washer, when water is not going out of the gun, it's being recirculated. So if you look at the diesel tank here, you'll top of the tank, you'll see two lines here. One of these lines has a straw that goes down to the bottom of the tank, and the other one just dumps out right on top. The one that has the straw that goes down to the bottom tank is the one where the fuel gets supplied to the burner, so that as the fuel level drops in the tank as you're using it, the straw is sucking it off the bottom, so you don't ever run out of fuel. The return line is just sort of dumping it right back on top. So when all the conditions are met, there's a little solenoid up here, right here, a little electromagnetic solenoid, little fuel solenoid. When the conditions are right, when you meet all your conditions, this little solenoid, the magnet is activated by a little current, which pulls a little brass pin up, and then all of a sudden fuel can start going through its little orifice, and then it's pressurized by the fuel pump, and whatever it's not being used gets recirculated back to the tank. So the fuel pump is always moving fuel in the same way that your pressure washer pump is always moving water. Just sometimes it goes out of the gun and sometimes it doesn't, by virtue of this solenoid. Now, in order for this solenoid to fire, and of course you got a little fuel filter here to clean up the fuel before it goes into the nozzle, which is a really tiny orifice, which is designed to spray that fuel out at, I think it's like a 60-degree angle at a certain gallons per minute. I think these are 3.2 gallons per minute, I think is what they use on these big 8-gallon per minute coils. But anyways, in order for this fuel solenoid to activate, right? Now, considering that this thing is on, it's got power to it, which means the fan is blowing air through the coil. There's an arc coming across the electrodes, which is gonna ignite the fuel, but the fuel's not coming out. In order for that solenoid to fire, 3 conditions have to be met. They're very simple. These things are super easy to work on and super easy to troubleshoot. Condition 1 is you have to have the master power on. In the case of these Mighty machines, you just hit the burner switch. So when the engine is running, right, when the engine's going around, it's turning the generator, which is supplying power. And when you hit the switch, that power is allowed to go and power the burner. So that fan starts spinning, that fuel pump starts spinning, but no fire is happening because the solenoid needs 2 other conditions. The second condition is the temperature, right? So we have a thermocouple, which is sort of screwed into the outgoing water supply here. It measures the temperature of the water. If I have my temperature, say at 160, and the temperature of the water is below 160, then that switch is closed, right? This is the way this thing works. It's mercury comes through here. Basically, mercury expands, and when that temperature is hot enough, the mercury expands, pushes a little pin, and then 2 pieces of metal come together, closing a circuit, which allows current to flow. But there's another interruption in this circuit, which is your pressure switch right here. This is condition 3. So this right here senses when the machine is in bypass mode or you're spraying out of the gun. You've noticed that when your machine is in bypass mode, it's like the line you know, the line out to your pressure hose is charged, but it sounds like your engine is not loaded, like it's not working hard when you go into bypass mode. That's because it's not. The unloader valve dumps all the pressure behind this portion of the unloader valve. So as the engine, when you let off the trigger and all of a sudden your engine just sort of sounds like it relaxes and it comes back up to full RPMs and it's not working that hard, that water is going around in a circle, but it's not pressurized. You're sensing that pressure. Basically the incoming pressure to the unloader valve. So basically between the pump and the unloader valve, you can put these pressure switches, you can mount them right on the pump, you can mount them on the intake, you can put them anywhere as long as it's before the unloader valve, in between the unloader valve and the pump. So when your pump starts working, when you spray the gun, right, when you squeeze your trigger and water starts going out of that little constriction in the nozzle in your tool, your wand or your surface cleaner or whatever, then all of a sudden the engine starts working really hard because it's forcing as much water as it can through that nozzle and it's not recycling the water. So that causes the pressure to go up, and this switch is designed to sense that. So if the switch senses pressure, the water temperature is correct through this thermocouple, and the master power is armed. If those three conditions are met, then this little fuel solenoid is allowed to open up and let fuel go through. If you let off the gun, or if the temperature rises, either one of those two conditions fail, then the burner will shut off and stop sending fuel across the electrodes and you will get no fire. So super simple, three conditions. And that's really all you ever have to troubleshoot in these things, is which condition is not working. So I've already gone through the prerequisite stuff because I don't want to have a super long video. I've already put a tachometer on the engines, made sure that they're, you know, as they get older, the carburetors get a little dirty, and a brand new engine will run a little bit faster and a little bit smoother than a 10-year-old engine. You don't necessarily have to replace the carburetor, but you can like fuck with the throttle screws and just kind of get the thing back up to 3,600 RPM. That's what you want, 3,600 RPMs on all these small engines, pumps, blowers, all that shit. Now, of course, the pumps, these belt-driven pumps don't turn at 3,600 RPMs. I think they turn at, I want to say 1,800. I think it's exactly half, but I'm not sure. It might be 1/3 or 1/2, but there's gear reduction there. And let's see, it's exactly, the pumps turn at 1,800 RPMs because there's a 10-inch pulley on the pump and there's a 5-inch pulley on the engine, about something like that. So the pumps are running at half the RPMs of the engine by virtue of the gear reduction with the different size pulleys, but the generator is running at 3,600 RPM. So if the engine, turning the generator, if the engine's not quite right, what'll happen is it'll, if it's a little tired, or maybe some screws have vibrated loose, or the throttle tension spring is a little worn, it's not quite as tight as it was when it was new, what'll happen is the engine will run a little bit slower, and the generator will be running a few less RPMs, which means its voltage will come down a little bit, and that can cause problems with the burners being kind of smoky. So you've all noticed, if you've had a hot water burner, sometimes a little puff of smoke comes out. That's not that problem. You'll notice the power supply problem when you're like solidly spraying and the burner's just working and it's just always a little smoky. It could be that your fuel air mixture is off, but it also could be that you're just not putting enough current across those electrodes because you've got so much power coming through those wires. The squirrel cage fan and the fuel pump are eating up a bit of that power, and then you have on top of this thing, it's not actually fired by 120 volts. This little part right here, I'll show you this in a minute, but this is the transformer. This takes 120 volt current at, I think this thing runs at like 5 amps. Let me have a look here. I'll find out later. Oh yeah, it's on the motor. Let me have a look here. I'm not gonna be able to get the camera on it. This thing runs 115 volts at 3,450 RPMs. That's good. Okay, that's awesome. That means you can set the engines at 3,600 RPM unloaded, and the RPMs always come down a little bit when you press the trigger, when you squeeze and you're spraying. So that means this thing is putting out its full voltage that it needs. It's getting at 3,450. So let's see here, and amps is 3.2. So this thing requires 115 volts times 3.2 amps. It's about 350 watts. We got 3,000 watts from our generator. So we have a balance of about 1,800 watts that we can use that generator for. The auxiliary plug, we could lights, fans, pumps, shit like that. We got about 17 amps to work with. It's I think it's 24. This thing takes off 3. We'll just round it up to 4. So we got 20 amps to work with. That's pretty good. 20 amps at 120 volts. That's well, that's about 2,050, 2,500 watts, something like that. That's quite a bit of power extra to have at our disposal. But anyways, that's beside the point. The point I'm getting at is that, you know, these things, if they're not getting the full complement of power, it can cause the burners to be a little smoky because not quite enough current is coming across. What happens with this transformer is it takes this incoming 120 volt power and it drops the amperage down to like a fucking fraction of that, and it bumps the voltage up to like, I don't know what it is, but it's something crazy like 17,000, 10,000, 20,000 volts. The volts go way up, but the amps go way down. So you have this really hot, high energy, high frequency arc, but there's not a lot of amperage there. And I'll show you that in a minute. There's a way to test that with a screwdriver, an insulated screwdriver. You can see and make sure that that's working without actually pulling the burner out and then looking to see if there's an arc across the electrodes. You can just pop this up, stick a screwdriver on it, and you can literally see the arc with a screwdriver. So we'll get into all this in a minute, but I've already gone through, adjusted the engine RPMs, make sure everything's running. One of them was running a couple hundred RPMs low, but they're all tip top now. And actually the brand new engine was running about 150 RPM fast, so I backed it off a little bit. And we don't need all that power, it's just unnecessary. So we're gonna take a little break here, do a cut, and then what I'm gonna do is pop the transformer off one of these things and show you guys this arc, and then we'll get into this, pulling this burner off and getting all the parts cleaned up, because what happens with diesel fuel is like a less refined fuel. It's really dirty, it's sooty, and after a while you get a bunch of this like carbon shit built up all over the parts, and it just causes the airflow to be less even. The electrodes get dirty, but if you get all this, take all these little parts off and you clean them up, put them all back together, then you would readjust the incoming air. There's some slots you can adjust that control how much air gets mixed with this cone of fuel as it's sprayed out and atomized. That's very important. It's got to be perfect, or it'll smoke white or smoke black, and that color of smoke will tell you if you got too much air or too little air. But you want basically no smoke, no black smoke and no white smoke. Black smoke is not enough air. White smoke is white smoke is not enough air, unburnt fuel. Black smoke is too much air, not enough fuel. So we'll go through all that. And yeah, and I think while I got you here, we'll talk about engine speed and governors real quick. Since I have this other broken down engine up there, you can see all that stuff. I want to show you guys how you set the engine speed in case you got questions about that. I'm not going to talk about fucking with the governor, just dicking around with the throttle a little bit so that you can make a little couple hundred RPM adjustment without doing a governor adjustment. Okay, let's go over here and have a look at engine speed control on these Honda engines. And we are going to be taking a little dinner break here. Jenny, say hi, Jen. Yeah, baby. She went out and got us some, it's Saturday night, you know, and I'm working here at the shop because we're getting ready to do our thing on Monday. I'm super excited to show you guys the first night on the big project. We're gonna do the first phase, but she got us some Famous Dave's barbecue. So we're gonna take a little break, set up a little dinner table on the welding table, and stuff some barbecue in our face holes, and then we'll get back at it. So I'll be back in a minute. Thanks, guys. Okay, peeps, we're having a look at the back of an engine here. Now this engine came in a pressure washer built by Mighty M. And when they do that, Mighty M and a lot of these companies, they take the throttle control arm that you have on the front of the engine and they disconnect it. And they just set the engine to 3600, and it always runs at 3600. You don't have a throttle, you speed up or slow down. Like for example, this one over here is a new engine that was a replacement. This one has still got the throttle linkage still attached to the engine, right? And the choke, the factory choke and all that shit. Mighty M puts these remote starts, you know, a little remote start key and a remote choke knob, and then they just set the engine to 1 speed. So like on this one over here, if you have a look at it, all the throttle linkage has been disconnected, and there's a remote key they like to mount up on their own panels. I like to get rid of that shit because those remote keys are a fucking pain in the ass. But you can see if I move this, there's no cable connected to it. You're not changing the engine speed. So let's talk about how these engines, if the throttle is just in one space all the time, but your engine is subject to different loads,
how does your engine always stay at 3,600 RPM? Now, I'm not gonna go into too much detail here. There's a million videos talking about the way the governor works on a small engine, but we'll give you a brief overview, and you can go check out somebody else's video to see the exact workings and how to adjust these things. But suffice it to say, let's get into it a little bit here. As your engine's in bypass mode, it's not really loaded at all. There's almost no resistance on the pulley, and it's just running. But if it were taking the same amount of fuel and air that it was taking under load when you're pushing all that water out of an 8-gallon pump under load, and you had that same amount of fuel and air going through here, this engine would speed up to, and it would eventually blow up. So you have to have some mechanism of automatically slowing it down, almost like artificial intelligence, but there's no intelligence. It's just the properties of metal. So mechanical forces stay in balance to keep this thing always running around 3,600 RPM. So you generally want to set them to 3,600 when they're in bypass mode, and then they'll run a little bit lower, maybe 3,500, 3,450, 3,580, something like that, when they're loaded up. The way this works is as the crankshaft is spinning around, it's spinning at a certain speed, right? Then on the backside of the engine in the cover, you have something called a governor gear. This turns with the engine. Now, if you look at this thing, you'll see these little things that fly out when this thing spins by virtue of centrifugal force. Now these are called flyweights on the governor gear. And as those flyweights come out, they're sort of on like a little cam hinge. And as they come out, as this thing spins, you see that rod in the middle come up? So the faster this thing spins and the more centrifugal force is forcing these little arms out, the harder that little pin is gonna be pushing upwards. Does that make sense? And so obviously this cover is gonna be kind of picked up and be on the back of the engine here. This governor situation, right, contacts something called the governor arm, which is right here, where that little pin pushes on this lever right here. Now let's look at what happens when I push on that pin. See that spring move? So the engine, and this right here, this is basically the throttle arm right here. This actually, what this does right now, this backs the engine throttle off. So basically this spring is holding this thing at like full throttle, or the maximum throttle right here. So and that's what this screw is. The screw controls the top end or the low end, I can't remember which, and the other one controls the low end. So this whole thing right here is locked into position. This would normally go up, this would normally move back and forth with your throttle arm, but it's locked into place. So normally what you have is a high limit, a high power limit. That's this screw. When you crank the throttle all the way up, this thing will hit against that screw, which has a setting, and it won't go any further unless you adjust the screw and like back this screw off. Then you could put more power to it, in a sense. You could do that. And then this over here would be the low or the idle limit screw. So you would back this off, and then your throttle lever could go back and forth, and you could adjust the spring tension. But basically, the engine speed is a perfect balance between two mechanical forces. Now, those two forces are the tension of this spring right here, and I guess probably that one too, but that's the main one. That's the throttle control spring. And then also the centrifugal force pressing up on this thing right here. So as the engine speed goes up, that pin is gonna push up harder and harder and harder. And so what happens is that force finds a balance with this spring, and this thing right here will eventually be like, you know, it'll find some little happy place. And as the engine speed goes up, the governor, as it spins faster, will push on this thing harder and slow this engine down. So the faster it goes, the more it's gonna wanna try to slow it down. And conversely, the slower the engine speed, the less pressure, and the more this spring right here is gonna pull the engine back to a high RPM state. So it's just a balance of forces. So now even when the throttle cables are connected to this thing, you're not controlling the butterfly valve directly. Like you think in your car, like it kind of feels intuitive. Like when you press on the gas pedal, you open up the throttle body in your car, more air, more fuel, all that stuff happens. This, you're not doing that. When you crank the throttle all the way up, all you're doing is putting tension on this spring. That's all that happens. Let's go have a look at that over here. So my throttle cable is not actually directly connected to, it's kind of hard to see, but it's down in there. That is the, what is that? The little linkage that goes to the butterfly valve in the carburetor, which opens up and lets more air through. It's not directly connected to that. It's not what's happening. What's happening is when I pull up on the throttle, let's look under here. That's it. See that spring? All you're doing is putting tension on that spring. That's the throttle. That's full throttle. That's idle. Full throttle, idle. So as I go up to full throttle, now my governor has to fight against the tension of that spring, and they find a happy middle ground at 36 RPM when they're set, 3,600 RPMs when they're set properly. That's how these work. So you're not actually accelerating your engine directly. All you're doing is putting tension on the spring, and it's the tension on the spring and the combination of that and the pressure of this gear pushing up on that little pin is what actually tells this engine how fast to go. And that's really helpful because, you know, as you're pressure washing, you don't have a gas pedal. You don't want to fuck around, accelerating your engine and slowing it down as the power output is needed, you know, through resistance to the pump and the generators and all that stuff. Or for example, like on one of those vacuum trailers, you know, over here, here's another example. Now, if I get this vacuum going, I close up the hatch and I start it up and I just open one of these valves, it'll breathe and there won't be that much resistance on the engine. But as I have a couple of vacuum hoses, one on the other side and one on this side, and you know, one of them's got a bunch of water in it and one of them doesn't, this thing has a lot of variability in how much resistance the engine is facing. So that's all moderated by that gear and that spring. That keeps this thing running at one smooth speed and providing smooth, even power output as the needs arise and as the conditions change for what is basically resisting the power of the engine here on the pulleys here. So as you know, there's like, let's suppose I like stuck my hand over the vacuum hose on both of them or closed off all the valves, all of a sudden the engine would face a lot of resistance. It would start working really hard, but it would speed up because as I slow this thing down, that governor gear starts slowing down. The centrifugal force on those flyweights gives out and that spring starts to kind of take over, opening up the throttle more and providing more fuel and more air, which causes the engine to speed back up. So it's just a balance of metal mechanical forces. It's a balance between spring tension and centrifugal force. That's what controls the speed of your engine. That's what you got to get a grip on before you go and start fucking around with your burners and trying to get them to be not smoky. You got to make sure all that other stuff, that prerequisite stuff, is functioning properly before you get into that. Okay, so that's enough on the engine speed. We're going to go into the burners now. All right, guys. Okay, guys. One of the reasons why I like to use these 120 volt systems is they're just more versatile and you got more options in case things go wrong. So, coming off the generator here, when these things come out of the factory, you know, there's just a 3-phase or a 3-wire, you know, standard 3-prong plug coming from this built-in generator that supplies this power distribution box. What I like to do is cut these wires and just splice in like a normal 120 volt house plug. The reason why I like to do that is because, you know, it's a pressure washer and a generator right here. And, you know, you spring a leak and the generator gets hosed down with water and causes these things to stop working. And it just sucks when you're trying to, or even on the engine-powered versions of these, the 12-volt burner systems, which I don't recommend buying. Stay away from those, they're even worse. You know, you'll get water on the front of your engine or just rain causes your charging system to stop working, your burner stops working. Well, as a quick workaround, if you're not getting power from your generator for whatever reason, you can just unplug this and then plug this into a wall. You know, a lot of job sites, you got, especially working on houses or commercial buildings, you can just run an extension cord to a power outlet and all of a sudden, bam, your burner's working again. And it's just an easy solution. So I like to whack these off and just put regular old house plugs on them so that the power distribution box has another option. I can basically plug it into a wall and keep working if my generator goes down. And they go down all the fucking time because, you know, shit happens. So, I'll plug this back in real quick. Now we're going to go over here and I'm going to just tell you what we're going to do here. So, to get these burners off, come in closer. This comes from that power distribution box. There's 4 wires here, but the generator's actually only using 3 of them. I just cut off I cut all 4 of them. Because these things are wired to be either 120 volt or 240 volt system. So the generator will work either one. But what I always do with these burners, first thing I do when I get them, is I'll take the main power supply wire and I'll cut these and I'll put little butt connectors on them so that we can just unplug these things and make it easy to remove this generator. Because if you don't do that, you have to take this thing off and undo all these wires, and it's the pain. Yes, it's real easy to just have some butt connectors you can just unplug. What has to happen is this has got to come off. There's 3 mounting bolts and 2 fuel lines, and that's it. Once you get these 3 mounting bolts and these 2 fuel lines off, this thing will just come right out, and you can just take it and put it anywhere you want and work on it. It makes it a lot easier. So we got our 3/8 stud mounting bolts, which is a 9/16 bolt on a 3/8 stud, and then we got our fuel supply line. So this comes from so this is the side that has the straw that goes down to the bottom that pulls fuel out, sends it through the filter, through the pump, and then whatever fuel is not being used gets sent back through this line. This is the return line to another fitting on the tank and just dumps it back into the tank. So this fuel pump, I think it moves like a couple of gallons a minute. It's a lot, or maybe like 4 or 5. So, that entire tank of fuel will move through this pump like every 5 minutes. It's like a lot. So we'll go ahead and unbolt this thing, set it on the floor, and I'll show you the internals there. Yeah, like that. Okay guys, right here, what I've done to simulate the engine running so that we can see what's going on without a bunch of noise, I just went ahead and plugged in my power distribution box to an extension cable, to an extension cord, so we got power going to our burner. The engine's not running, but we're getting it from the wall. So we'll turn this on, and you'll hear the fan kick on. Now this burner can fire if those other 2 conditions I mentioned were met: the pressure switch and the thermocouple. So if I wanted to, I could take this little switch apart, stick a little screwdriver and hit the little button in there, and then this burner would fire. I don't want to do that right now, but the temperature's already below the thermostat, the power's on, so the only thing keeping that burner from firing right now is the pressure switch, condition 3. So if this thing's going, you can hear it. What's happening is this motor is turning, the squirrel cage fan is moving air, and the fuel pump is recirculating diesel in a circle. Now, the first thing you can check if these things stop working is the electrodes, and making sure that the transformer, this little thing on top, come in close. This is the transformer. To make sure that this thing is working, you can do a quick test to see that arc is coming across your electrodes. There's a couple of bolts you can take up here, little 5/16 tap screws, and then this thing will open up like a hinge, and then you can have a look, and I'll show you how to determine real easy with a screwdriver. A screwdriver with a plastic handle that insulates you from fucking like 20,000 volts, or whatever these things run at. I forget the actual voltage. An old friend of mine who's a furnace and repair guy taught me this trick a long time ago, years ago, and I've been using it ever since. We'll take this up, lift off the transformer, and you can see it's super steady in there. You can see the contacts, but this is what we're concerned with right here. We want to see if arc is coming across. A little bit of dirt on there. So our transformer is working. We know that that's fine. Now when these springs right here, that spring and that spring make contact with these 2 electrode pins right here, these spring-loaded pins. These things extend into the housing and they come to a couple of little points, which is very important, and then arc jumps across. That's right in front of the fuel nozzle. You'll see that in a minute. Okay, cut that. Coming closer. Okay, so I think I am going to go ahead and pop this pressure switch apart real quick, and I'm going to show you what happens how these pressure switches work. Oh, that's a little tiny. I'm going to get a smaller screwdriver. Not be way too long. You guys know that. Power tools make everything move faster. I guess I don't really need to say how stupid it is to do this inside of a building. But, you know, and this is not a professional way to troubleshoot these burners. What I'm showing you is the ghetto do-it-yourself way, which is how most of us operate. Okay, come over here and have a look at this real close, Jenny. Now, in here, one of the reasons why burners stop working, because you can't figure out why you're not getting hot water, is there's high pressure water in here, and it's pushing a pin through an O-ring, and when that O-ring leaks, or if water gets in here, it'll cause this switch to go bad. They get, you know, there's 3 little wire contacts, they get rusty and corroded, and they basically stop working. But that little white piece of plastic right there, down in there, that is the actual switch. If I were to press that, you'd see fire and smoke come out of that exhaust right there. Okay, go ahead and take that. And I'm gonna go ahead and simulate pressure coming through the high pressure line. See the burner fire in there?
Yep.
Now, I don't want this to get too hot because there's no water cooling it off. That's how that works, guys. Simple pimple. Okay, guys, real quick. With these pressure switches, here's a little trick for you. If you look on the back side of this pressure switch here, you'll see a little hole right here. That little hole right there is a drain hole, so that any little bit of water that gets by the O-ring in this thing right here, there's like a little O-ring in this section right here, any water that makes it through could drain out of this hole. So what you should do is orientate these things vertically, or maybe like that, so that any water that does get by the O-ring will just fall out before it gets into the electronics. So you can position them like that. I usually leave them like that because I don't really care. I just go through so many of these things. But that little hole right there, that's designed to be a drain hole for any water that gets through there. So to make your pressure switch a little more resilient and last longer, just turn it down like that, and try to have it up at an angle a little bit if you can, by virtue of the fittings, and that'll help it not get water inside of it. Little trick for you. Okay, so we got the power turned off. I'm gonna go ahead and unplug my fake power supply here. I'm gonna go ahead and disconnect my wiring, my personal quick disconnect wiring. Probably should have like a professional 4-pin connector, but I just do these old butt connectors because they're easy. We're going to take off the fuel lines, and the way I like to do the fuel lines is just put like a vice grip or something on them, pinch them, because if they're below the fuel tank, they'll leak fluid all over, or leak fuel all over the place. And the return line is not so much a problem, but the supply line that comes from the bottom of the tank, it'll just siphon the entire damn tank out on the floor, so you just want to put a vice grip on it. Just pinch off that fuel line pretty close to the edge, flatten it out without cutting it. That's a little tight. There we go. And I can take off the little hose clamp. See, I'm going to back that off. Touch. Like right there. This is the fuel supply line we're taking off. And these things have been on for a while. It's easier to get them off the hose barb if you just take them and kind of break them loose. Now we should be able to just pop it right off. The hose barbs are like, the hose fitting is like kind of barbed, so it kind of grabs the hose. Doesn't work. With a screwdriver, just kind of pry it down. There we go. Okay. Then I'll take this supply line, just put it above the fuel tank. Or better yet, I'll drain the supply line all the way out just by using gravity. Let all the fuel fall out of that line. And then I'll just secure it like this so that it won't siphon fuel out all over the floor. Just do something with it. Move onto the fuel return line. That fitting. And all I'm doing is just putting the screwdriver at the top of the fuel line, just sort of camming it down, just to kind of push the fuel line off of the barb a little bit, because I don't want to cut a hole in the line. Nope. Feed this through. I'm just going to make a mental note and make sure I don't hook up the wrong line, because if you hook up the return line to the intake, there's no straw. It's just going to be pulling air through the line. It won't really hurt it per se, but it won't get you fuel. So I'll just make a mental note. The one on the inside is the return line. Drain that out. Set it aside. Okay. Now the next thing I'm going to do is drain out my fuel filter just by opening up this little petcock right here. We're going to drain out the filter, and any water that was in here will be sitting on the bottom of this bowl, so you'll drain out the water and the fuel, whatever was in there, all the goobers. You see that empty out? Give that a minute. And this is a good time to replace your fuel filter, but I'm not going to bother doing that because this thing's not slowing down, and I think I got one fuel filter laying around, but they're fine. We don't need to take them off. Okay. Tighten that back up. Now I was real careful to clean this thing out first, so we got a filter in place, so I'm just going to pour this diesel right back in the tank because I don't want to do anything else with it. Any little bit of sand or gunk in there, I'm just going to leave it in the bowl. And I'm just going to get rid of the bulk of the fuel because diesel fuel stinks and I don't want to have it laying around. Well, there was some junk in there. Some pretty good sized little goobers in there. Some sand and some shit like that, and you know, whatever. It's not back in the tank now. I'm gonna go ahead and pop off this transformer cover once again. Show you guys what's happening. Actually, no, I kind of want to do something really stupid. What I want to do is fire this burner when it's out of the coil, so we can see what's happening here. This is probably a really stupid idea to do right in my shop, but you know what? I'm a little bit of a redneck, and let's see what happens. Let's do a little. This is definitely something. Put the video on me. What I'm about to do, don't ever fucking do this. I'm about to do something really stupid because why not? Let's just go ahead and give it a try. Okay, let's have a look inside here. So what we got is our squirrel cage fan. When the motor's turning, that fan turns, which forces air out of here. The transformers connectors hit these two pins, which are just two metal pins that come out to these two electrodes right here. You probably can't see them. Let me put a light on there. If you look down in there, you'll see an electrode pin right there, an electrode pin right there. They're right in front of the orifice of this nozzle, which is real hard to see. Let me clean that off a little bit. That's the fuel nozzle right there. That little tiny hole is where the fuel comes out. And that fuel comes out at a 60-degree angle. And if I were to unscrew that nozzle, you'll see some numbers on it. 3.2 gallons per minute at 60-degree angle. It's just like a pressure washing tip, only it's for diesel fuel. And those two electrodes, the arc comes across from that point and that point right there. So as the fuel comes out in a cone, it's ignited by that arc. Now those three conditions from that fuel solenoid on the solid here, what happens is this is always arcing across right here, and then the fuel is allowed to come out or it doesn't. So the arc is always happening when there's power on there, but no fuel comes out. So what I'm gonna do next is I'm gonna plug these wires back in, plug that in there, and we're gonna see what this flame looks like when it's not inside the coil. It's probably gonna be a giant fucking disaster. This may be, I may blow me and Jenny up here in the next 5 minutes, but let's see what happens. Might as well try and do something fun, because I've never done it before. Okay, got that. I want to show you guys the arc. Come over here. Go. You can see the arc coming across. Oh no, this is something I didn't know about. Getting close. Stay out to the side. You can see that the airflow from the fan is pushing the arc out in front of the nozzle. You guys see that? Get in real close. Alright, that's what's going on in your burner before fuel gets to the nozzle. So we're going to go ahead and hit that switch. See what happens. Okay, ready? I'm just going to touch it. 3, 2, 1. Oh, Jesus Christ. That's not that bad. A lot of white smoke. The reason why that extra white smoke is there is because we're not in an enclosed situation. That's your hot water burner in action, guys. Okay. Alright, so there's potentially like a couple of different levels of maintenance you can do on this thing, and I think because I'm feeling kind of lazy tonight, I think I'm just going to do the easier level of maintenance, because this thing's running really good. It doesn't need to be adjusted as far as the electrodes, but I think that'll be a good topic for another video. So let me show you guys what I'm talking about. So when you're rebuilding these things, come in close. What's really important in the way that these things work is, let me get that flashlight. Yeah, I got it. Okay, so what's really important is the distance between these electrodes. And these are controlled by these mounting screw right here. So if you loosen up this bolt right here, there's a big 3/8 bolt right there. You loosen that bolt, and then you can rotate these electrodes. And because they have bent ends, they kind of like get closer together and get farther apart, right? Now you can also slide these in and out. This whole electrode can slide in and out, and you can also rotate it left and right. So if you're looking at it, what's really important is the distance from the tip of the electrode to the tip of the nozzle. So this distance here is important, it's critical. What's also important is the distance between the electrodes, and then also the standoff, which is how far out past the edge of the nozzle these things are sticking. So if you were to take the cap, you can't do it, but if you were to take it and look at it edge on, you would see, like let's say that's the fuel nozzle, you would see the 2 electrodes sticking out a little bit past that. So I think this is supposed to be like, I forget, I think it's supposed to be like 1/3 of an inch or 1/2 inch. There's a sheet that details all this information. And all you gotta do is, it's basically one thing you have to do, you loosen up the fuel line, and then the whole apparatus slides in and out, but then you can also adjust the individual depth of these electrodes. But basically, you have to get these 3 distances just right. And when you get them just right, they light up and burn really clean. If you don't have them just right, they tend to be a little smoky, and then what you'll see is a little bit of fuel come out, and it'll take a minute for like a split second for the arc to ignite the fuel, and you want to get a little puff of smoke. But if you get these things adjusted just right, they work out really good. These things don't need to be adjusted at all. They just need to be cleaned up. So what we're going to do is take the cap off, clean off the electrodes and the nozzle, wipe that out, and I'll show you how to do this. It's real simple. You have a couple of screws on the side here. I always start on the side. There's a Phillips screw right here, and we're just going to take this cap off. And of all this stuff, this is probably the most important thing to clean, because this little end cap that I'm taking off is the diffuser that basically causes the air to come out in a certain pattern and mix up with the fuel. There's a Phillips screw on the left side and a Phillips screw on the right side. And you just want to be careful that you don't strip out the screw. guess it wouldn't be that hard to replace. But I'm gonna pop. There we go. It's up. A lot of that shit will just fall off, but what I'll do is take this in the sink and maybe put some diesel fuel and some brake clean on it and a wire brush and just get all that soot off and just get it cleaned up down to bare metal. And now you can see they have this sort of like these like little fan blade looking things here. As the air's coming through from behind, the air hits this apparatus and it forces it to come through and kind of spiral, and it just helps to mix up the fuel in the air. Get all that cleaned up. It's actually not that dirty. And you can see that there's like nothing on the backside because there's no fuel back there. All the soot and the carbon gets caked up on the front side, which actually helps them run a little bit longer. But in here you can see the nozzle and the electrodes. And there's also, you can unscrew this fuel nozzle. I believe it's a 9/16 wrench, if I remember right. And I think we will take that out so I can show you the fuel nozzle, because these things, we wind up replacing these things probably no less than once a year. These are actually going on a couple of years. They haven't gone bad yet. But what happens is, it's like a diesel injector. There's a little bit of silicate in the diesel fuel. We don't really have so much of those problems anymore because the fuel is getting cleaner and cleaner. But what happens is that little tiny hole, that fuel nozzle, is just like a pressure washer nozzle. It's a very precisely machined orifice, and they wear out. As there's a little bit of sediment, a little bit of abrasive sediment, very fine sediment in diesel fuel, it wears out that hole, and it causes the fuel as it's coming out to not come out in a perfect cone and be not completely atomized. So you just put a wrench on this, screw this out. There's a filter, a little fuel filter, permanently mounted like in the backside of that nozzle, and I think I got a new one. I'll show you. I'm gonna go grab a new nozzle and show you what they look like, and we're gonna pull this one out and clean it up. Got that? Okay, I got a nozzle here. It's not a new nozzle, but it is a nozzle. This is the way they come, a little plastic container. You can see that this is a 3 gallon per minute nozzle, and the cone of the way the fuel comes out is a 90-degree cone. So it's like a pretty wide cone of fuel that comes out. That's how they come, and this is what they look like. They just screw in, there's some thread, and there's a little filter on the backside there. So a lot of times what I'll do is I'll just take this thing out and dunk it in WD-40 or diesel fuel and just take an air compressor to it and blow the little screen out. And just make sure the screen's not clogged up and the fuel's not having a hard time getting through there. And I don't really know a good way to test to see if the if the fuel is coming out in a perfectly 90-degree cone or if it's like misatomizing. But the best way to figure that out is just tune everything up the way it's supposed to be. And if it's still not igniting properly, then probably your nozzle orifice is worn out. But honestly, I don't know if I've ever even seen one be worn out or how much of a problem that actually is. So that's a new nozzle. Okay, that's it, Jenny. Come in close. Okay, so now you just want to be careful when you're taking these nozzles out because they get kind of set in there pretty good. But just get a good grip on this thing. I believe it's a 5/8 wrench. Yep. And you can't really get a socket on it because the electrodes are in the way. You could rotate the electrodes out of the way, but then you'd have to re-put them in there. So I'm not going to bother doing that. I'm just going to kind of do this with a box end wrench and just be as careful as I can. I'm going to put this on the nozzle and then give it a little. There we go. You got it. Okay. And you can see I nudged that electrode, but it's basically in the same position. That's fine. Just going to carefully rotate this thing out, and we're going to take an air hose to it and check the filter on the backside and just make sure it's not plugged up. And then with this nozzle out of there, it'll make it a little easier for me to clean those electrodes up. There we go. And that is in basically like perfect condition. There's nothing wrong with that. So I'm just going to wipe all this shit off.
Okay.
Nice and close. Go ahead and start filming. Okay guys, so what I'm doing is I'm just going to take a wire brush, clean this thing up. I'm not going to make you sit through this whole process. I'm going to knock all the soot off this thing, hit it with the air compressor. I might spray some brake clean in there, clean all that shit off. And we'll come back in a minute. But basically, wire brush and a little elbow grease. That's what I usually do. And I'll wipe the electrodes off. clean out the inside of this housing. You know what? It actually is going to be easier to take this thing apart and clean it. So now the way these things come apart is right here. We can take out the whole assembly of the electrodes and the nozzle holder without actually changing their orientation by loosening up this jam nut or taking off this fuel line right here. I believe that is 1/2 inch. We're going to take off this fuel line, bend it out of the way, then we can loosen up this holding nut. And what's going to happen is I'll know exactly how deep. You can see there's a little capture nut right here. This nut right here is what controls how far in and out the electrodes and the nozzle assembly are in and out of this housing right here. That's important. But it's so dirty, I'm going to be able to see exactly where that is. I could take, I could score it right there and just sort of draw a line around this so I know exactly where this plate is. Where this is set is important, and everything else doesn't have to move. So I'm going to go ahead and zip this apart real quick, and it'll just be easier to clean all these components up if I take them out. So we'll do that real quick. Okay, so we're going to take off the fuel line. So the fuel line just is like this sort of copper steel tube, but it's kind of flexible. I'm going to take this off. I think it's like 7/16. Looks like it's, actually it's 1/2 inch. Looks like it's a 1/2 inch nut. And it's basically a comp fitting, a compression fitting. Pop the fuel line off, that's free. And now all we got to do is loosen up this, this like jam nut right here. And that capture nut. I'll take that off real quick. That should be 5/16. Little 5/16 self-tapping screw. And now it still won't move because there's a little capture nut right here, so we'll loosen this up. And now you can see that this whole thing is kind of loose now. But in order to get this out of here, I got to take this all the way up this threaded stud. And then we'll be able to get it out of here. Yeah, see, we can see right where that thing is. See that discoloration? So we won't need to like figure out where it goes. Here we go. So there actually is one more measurement that I forgot about. Okay, so when this cap is on here, right? The distance between the nozzle when it's installed and fully screwed in. I won't screw it all the way in, but basically this flat surface here, come in very close. This surface here, where it is in relation to this plate is very important, right? So you have the vertical distance between this electrodes and the fuel. You have the standoff distance, meaning how far those electrodes protrude out past the nozzle, and then how close together they are. Those three measurements, in addition to this surface in relation to that plate. There's 4 measurements you have to know, and there's a document you can download or look up on the internet that tells you exactly what these are supposed to be for this particular model of burner. And this is a little bit off. I'm just looking at it. I can see that one of those electrodes is up a little high. It's not really interfering with it. You can tell they're not that sensitive, but what I'm gonna do is loosen up this capture nut real quick, just barely. And I'm gonna rotate that electrode down a little bit so that they're a little more even. And this is just you can see it's just squishing these two. This is ceramic insulation right there, real dirty. If you loosen this up a little bit, then this thing will spin inside, see that? So I'm just gonna make it kind of uniform. And I do know, one measurement I do know is they're supposed to be between 1/8 and 3/16 of an inch apart. So if I go too far down, they'll get too far apart. So I'll rotate this one up a little bit, and that will work just about right. So I'll go ahead and tighten this back down. Carefully without moving them. There we go. That's what we want. Now it'll be a lot easier to clean all this stuff up. So what I am paying particular attention to is the very ends of these electrodes. Let's get all the carbon off of those. Bring them down to bare clean metal. Nothing else is really important, it's just kind of for looks. Sorry, bud. Not bad, buddies. So what seems to work really good is just a combination of a wire brush and brake clean. It's like both, neither one of them alone are going to work that good, but it's like kind of break it up with a wire brush and then just rinse it off with the brake clean. The brake clean does seem to act like a pretty good solvent. Okay, check her out. Cleaned up parts, baby. Bam! All right, just gonna do the housing there, and then we'll just get a shot putting it back together. Thanks, guys. We're gonna put this thing back together, got all our parts cleaned up. All right, come in close. So we're gonna slide this in. This has gotta come through that hole, and this has gotta go through here. So we're just gonna pop this puppy in here. And this thing is held in that housing by these 3 points right here, just sort of like, see that? It just sort of is in there like that. That's the only thing holding that thing in there, and that nut right there, the fuel line nut. Scooch this thing through here. Pop that nozzle through there. Put the capture nut on. Right here. Look what I'm doing. Yeah. I'm gonna put that capture nut on to hold that in its proper place. And that's pretty much it. As long as you don't change the orientation of the electrodes relative to the nozzle, you don't really have to do anything except get that mounted in its proper place. And you don't have to reef on this, just a little bit. There we go. That's all you gotta do. Now we're gonna put the fuel line back on. Make this. Careful not to cross thread that. There we go. Tighten up that fuel line, this compression fitting. And then we're going to put our end cap on, and that's it. So the only thing that's important about this is that it can be rotated 180 degrees, but these mounting holes on the sides just got to mate up to these holes on the side. So pick one. Just kind of give it a tap in. Rotate it just right. Here we go. That screw in. That screw. There's a screw on the floor here somewhere. I'm gonna pause that. This thing's back together. We're gonna close up the lid. We're gonna mount this thing on back with those 3 bolts. Hook up the fuel lines and the power cables and give it a test run. So I'm not gonna bother you guys with all that stuff. I'm gonna get this thing mounted back on the coil, and then we'll give it a little test run and see how she burns. Should be burning pretty clean. We should see no smoke, but we may have to do a burner adjustment. Let me show you how that works real quick. Come on in real close, Jenny. So the easiest way to do this, I found, is just basically you open up the airflow and it'll be real smoky. It'll be like white or black smoke. And then you just close it up while it's burning until the smoke cleans up. And then after you get that done, then you want to do a couple of test pops. You want to see the startup smoke. You're trying to eliminate the startup puff and then the solid burning puff. And that happens via the air intake, which is over here. Come in and look at this really close on this side over here. Okay, so we got some air vents here. You got these vents here. And then you also got some vents on top. These ones are like closed up for some reason. So I definitely didn't do that. So we're gonna have to, usually it's a combination of, oh no, I'm sorry. What you usually wanna do is you'll start with these and there's like this sort of steel plate in these vents, and you'll just rotate this to open and close up these ports. Now, you can see that these are partially closed, but mostly open. If you're not getting enough air through these ones, you got a secondary plate back here that has additional vents. Now there's holes in this area. They're all covered up right now, but it's basically getting it just enough air. So I'm gonna put this thing back in. If it burns smoothly, I'm not gonna bother adjusting it, but if it needs an adjustment, we'll start with this one and then we'll feed up more air with this outside plate. So we got a couple of bolts here, right here. There's 1 bolt there and 1 bolt there. That holds this plate and allows this one to rotate or not rotate. Then you got a secondary one here on the outside, and these are not being used right now, but you would loosen this bolt and then just rotate this ring and expose the holes that you can't see to add a little more air. So it's basically choke it off and then keep feeding it air until the smoke cleans up. Real simple process. We'll do that on another video because I got one more burner to do, and it's Saturday night and it's late and I want to go home and sleep. So we'll do that some other time. All right, guys. We'll do a little test burn in a minute and then we're done. Thank you. puff of smoke, but it's once a day I'll do that. You don't want to run it perfectly. I've never been able to get that last little tiny bit of puff of smoke. That just has to do with I think it has to do with the fan. Like if you try to get rid of that puff of smoke, you can do it, but then you wind up having burning smoke later. So that's just what it is. I'm happy with that. This one's good. We're gonna call it good for this machine and move on. All right, guys, thanks. Hope it was helpful. We'll see you on the next one.